Okay there. So welcome back to Data Communication Networking Weeks 8 and 9 Part 2. So today we're going to be learning all about routing protocols and a little bit about the transport layer. So let's talk about routing protocols. So before we talk about routing protocols, we need to talk about routing. Why do we need to route, right? What is the point of routing? Well, routing is specifically used for two main reasons. One, it is used to route data from source to destination in an efficient and optimized manner by taking the best path available, right? Right. So there are four main things that a router needs to learn to do, good routing. So first things, it needs source address, obvious. It needs a destination address, again, obvious. It needs to know all the paths so that it can take the best path alongside of it. And it needs to maintain and verify the routing information, right? So what is routing information? How does it maintain and verify them? Well, the thing it does is it maintains things known as routing tables. So what's a routing table? Well, before we talk about routing table, we should know about two main protocols that it uses. One is connected and another is learned. So if a router has devices directly connected to it, it will store their addresses, right? It will store their IP addresses under connected. Whereas, let's say it knows the IP address of another device that goes through another router. Then it has to learn that specific device. And that will how it will save it. So usually we can say connected. It will save the destination address, right? And so it's basically the destination address or the IP address will be here. And if it is connected, it will know the specific port it's connected to. So it can be an Ethernet port, so on and so forth. But let's say it has learned another IP address, then usually it will be connected through serial ports, right? So here's a very important connection, distinction you have to make. See, a router, each of these devices have their own IP addresses, right? So this has an IP, this has an IP, this has an IP, this has an IP. This link here, it has its own IP address. It has its own IP, it has its own network address. Yes, you heard me right. It has its own network address, and that will be the learned address, right? The learned, that is going to basically be the next hop address. We will learn about it in a few while. So there are a few ways how it updates its routing table. One, using static method, right? So static method is an admin or administrator manually uh, manually configures the address, right? But it is prone to human errors and there's so much problems, so much maintenance, so much work. Hence, why there's something called as the dynamic method. The routers learn. And how does it learn? Through advertising. Learn and advertise and maintain a table. So it's automatic. It's completely automatic, right? It maintains the table, right? So what is learn and what is advertising? Well, advertising is essentially a router letting other routers or letting other routers know or share information with other routers on knowledge it learned, right? And learning is obviously learning from advertised data, right? So there is another small terminology which you should know, which is direct delivery and indirect delivery. So if a packet or data travels through only a singular router without going through external routers, it's a direct delivery. But if something had to go through routers or go through, hops, essentially more than a singular hop, then it is an indirect delivery. So we must first of all know about adaptive routing. What is adaptive routing? Adaptive routing is the process in which routers learn automatically, right? So it is basically the updater of the routing tables. But there's a huge disadvantage. This uses lot of space and processing power. Now you may be like, okay, fine, just add an SD card. Hey, just give it a bit more chips. Well, that is not how routers work, okay? So, and there's another thing. It doesn't save the, routing table like a Excel spreadsheet. No, all of it is commands. It saves it all of it as commands, right? So adaptive routing has two main separations. One is next hop routing, and this is the other is default routing. Next hop has two types: network specific and host specific. The network specific one, right? Network specific one does not hold much data. Okay, so this is used for large systems, whereas host specific is used for small systems, right? So it can hold a lot more data. And network specific does not what do you say broadcast the does not update the routing table every other minute. It only updates whenever necessary, whereas host specific, every single router is updated. Okay, so that's one of the main reasons, main difference between host specific and network specific, right? Okay, so now let's talk about code. Let's talk about the port specifically. So routing table updating methods. So we can see connected, there's static, and then there's finally default, right? Okay. So the static method, meaning we physically go into the router and we set up stuff, is we go into the router and we go into config terminal. We'll get the hashtag over here. What we must do is we should first of all write IP route. This is gonna hold the destination IP address. This is gonna hold the destination subnet mask, and this will have either the next hop IP address or interface, the the port in which it is connected to, right? Okay, so now let's talk a bit more in detail about dynamic updating methods, meaning automatic updating methods. So routing protocols allow routers to automatically advertise and learn from those advertised data, right? It'll share information about, hey, this route has been broken, hey, this route works, this route does not work, so on and so forth. So there are two main specifications here. One is IGP, other one is EGP, interior gateway protocol and exterior gateway protocol. Interior gateway protocol is a singular, within a singular small network, right? Whereas exterior gateway protocol is a set of networks altogether. So under EGP, there's something called BGP. I have no idea what it means. So IGP, it has two main ones, which is two main protocols, which is the distance vector protocol and link state protocol, right? So the distance vector protocol has, I'm going to put it here, DPV has two, which is RIP version 1. It's not a rest in peace. It's actually, I believe it's routing information protocol version 1 and RP version 2. Then we have IGRP and enhanced IGRP, right? Link state protocol has two, which is OSPF and IS-IS. Okay, so now let's talk a bit more about the RIP protocol. So we learned about IGP, EGP, but before both that we have something called AS, which is automated system. This is automated system is a collection of routers under a common admin. IGP is a set of ASs together or intra autonomous system routing, and EGP is a set of IGPs or inter autonomous system routing, right? So IGP has, as we discussed, two main protocols, which is one is the distance vector protocol. So let's talk about the first one, RIP version 1, right? So RIP version 1 updates the routing table every 30 seconds, right? So this is best used for small networks, and which is why it is limited to a 15 hop count. There's only 15 hops a maximum it can travel, right? So then there is RIP version 2. Basically, what these will do is it will select the shortest and the best route to send data through, right? Shortest and best route to send data through. And it does that by the use of algorithms. So essentially, it will take like the least, most. Okay, let me show it to you. In fact, so let's say that it wants to go from A to B. So A, B, C, D, A to C, right? So it can take two routes, one ABC or ADC. ABC is 8, whereas ADC is 7. And it will take the least taxing route, which is 7. And these values are just values, but this is just to give you an idea of what RIP is. So to configure RIP, we first of all need to go into a router, go into config. Then we need to put router RIP. We put outer RIP. Then we put network and we write the network IP address. We can write a number of network IP addresses over here. And after that, we click exit. And in Cisco Packet Tracer, we use no shutdown to like configure all this. To do RIP version 2, it's literally the same thing, except we have to put router RIP. We have to write version 2. And after you put all the networks, configure the networks, you have to put the one very important thing, which is no auto summary. And then you can put no shutdown and exit. So what's the point of no summary? Basically, RIP version 1 is a class, uses the IP class system, right? Whereas RIP version 2 runs on the prefix system, the classless system. So basically it says do not save this data, the class data and all that stuff, which is why we use no auto summary. Okay. Right. So RIP version 1 is class full, RIP version 2 is classless. It does not hold subnetting data. So subnetting means basically, as we taught, breaking one IP address into smaller IP addresses. It does not cannot hold that data, but this one does hold that data, right? This one does not support error checking. This one does support error checking. This is less secure. This is more secure. Uh, this uses broadcasting for updates, whereas this one uses multicasting for updates, so on and so forth, right? Right. Okay, and that is all about routing protocols. Just go through, just read up about IGP and EE. Sorry, not this guy. Read up a bit more about IGRP and EIGRP because I also have not much of a clue. You know what? Let's tackle it. Let's talk about it a little bit more. IGRP is basically RIP, but for smaller networks, right? Whereas EIGRP is enhanced. So it's like an enhanced version of it. But although it is for smaller networks, it can hold 255 hop count. It has a hop count of 255. Oh wait, it is not RIP. RIP is used for small networks. Sorry, my bad. RIP is used for small networks. So IGRP was introduced so that it can have a higher hop count than RIP, right? Okay. And finally, let us move on to the transport layer. Finally. So transport layer is very simple. Transport layer is the thing that differentiates between application processes, right? So the it provides logical communication between application processes and different hosts. What does that mean? Well, you can have multiple applications running on the same device, right? And each of these need a specific what do you call it? A specific uh, different type of protocol, something like that. So you can have Chrome or HTTP for website. You can have Netflix. You can have Skype or something like that. Each of these will have their own ports. So HTTP is 80, Netflix is something, and Skype has something, right? So what is the importance of having transport layer when we have a network layer? Well, we learned that the network layer uses IP protocol, which is unreliable, right? Its IP is unreliable. So transport layer uses TCP, which makes it a bit more reliable. It is guaranteed, right? And which is why we use TCP IP as a thing, right? So what is the point of having a port number? So port number is there so that we can differentiate between different applications. Differentiate between different applications. So here is how it works. There's the application layer, there's the transport layer, there's the network layer, there is the data link layer, and then there is the physical layer, right? So when it comes between both of these, between the transport and the network, right, there is something called a socket. Is it a socket? Yes, a socket. So a socket is used so that any process that goes through it can be bundled up into singular database. And this process is called multiplex. For instance, let's say there are 3 processes. All of them will become a singular data holder through the socket, and this is called as multiplexing, right? And the opposite way around is called as demultiplexing. So application will hold the message. Transport layer will add a transport header, make it into a segment. Then it will go through the network layer and it will add a network header that's going to make it a datagram. Then it's going to go through the link layer. It's going to go through the link layer. It's going to make it into a frame. It's going to add link header and link trailer. Then it's going to become into bits using the physical layer. Then again, it will be reconverted into the frame. the link layer will remove the frame and send the datagram to the network layer. Network layer will remove the network header, making it a segment, and resending the segment. Segment will demultiplex into different port transport, and sorry, the datagram, yeah, segment, it is a segment, right? So the segment is going to come here, it's going to become different segments, and the transport layer will remove the segment header and make it back into a message, right? So what is this socket? Well, the socket is an endpoint for sending and receiving data. Think of it like that, sending and receiving data. Okay, right. So now we have to talk about the TCP protocol. So there are three main parts when it comes to TCP. One, it is connection establishment. Then there is data transfer. And finally, there is connection termination. So this is the client and this is the server. Client, server. Client, server. So the client sends a synchronization message, which is basically 1 byte. The server sends an acknowledgement, and then the server sends a synchronization message of its own, and the client again sends an acknowledgement. So it's like saying to your friend, hey, good morning, and your friend's like, hi, good morning. Your friend takes your hand, says hi, good morning to you, and then you shake his hand again, right, in motion. So that is the connection establishment. Then after, what happens is the data is sent from the client to the server. Acknowledgement is sent. Server then sends the data again, and the client sends an acknowledgement also. Finally, the client sends a fin. Oh, by the way, acknowledgement is 0 bytes. Okay, fin message is equal to 1 byte. Server sends an acknowledgement. Sorry, and then the server sends its own connection termination fin message, and finally you have an acknowledgement. Now these are four-way handshakes. These are all four-way handshakes. But you can do something here. Instead of like having both of these together, both of these differently, you can have them together. For instance, you can use the synchronization. Then you can send the synchronization and acknowledgement in the same message. Then you can send an acknowledgement, right? So this makes it into a three-way handshake, right? So now you can make this into another three-way handshake. So it sends the data over here, and it can send its acknowledgement and data, and then this can send its own acknowledgement. This also is a three-way handshake, and this is known as piggyback, right? But can you do a three-way handshake over here? Well, you cannot, because it is not proper. So basically you should not follow a three-way handshake. A connection termination is always a four-way handshake. So we have to first of all learn about how sequence number, acknowledgement number, and finish number work, mainly sequence number and acknowledgement. So here is an important part. right? So initially, when there's a connection establishment, okay, there will be a sequence number, right? Sequence number. It will always be an ISN because it's an initial sequence number. That's gonna be, say, 1000, right? Initial sequence number 1000. And let's say it sends a date acknowledgement of, it sends an acknowledgement. Acknowledgement is 1 byte, right? So that is the first one over here. Now when this one, when the, so this is the, sorry, not server, that is the client, and this is the server. When the server sends its own this thing, what? Oh, sorry, this is not an acknowledgement. This is actually a, sorry, my mistake. So this is actually a synchronization message, right? So then the ISN will sell its own, that's going to be 5000, and it's going to send its own synchronization message with the acknowledgement message. Now, you know, acknowledgement is equal to 0 and synchronization is equal to 1. Now, the client will send an acknowledgement message of ISN equal 5001. What does this mean? Well, here's the thing, very important. This is very important. So this is how connection establishment works. Let's talk about connection data transfer, actually the data transfer. Now the ISN is 5001, right? It's expecting the 5000 first step. In fact, forget about this. Let's talk about a bit more. Let's say, well, I think it's sequence number over here. I'm not going to be sure. We will talk about this a bit more in detail later. But let's say sequence number is 1000 and it sends a data of length 100, right? It sends a data of length 100. So basically, since 1000 is also a number, the last one it will send is 1099, right? So it's going to get the 1099th value here. And then it's going to send an acknowledgement of 1100. Basically, it's saying, hey, I am expecting the 1100th data from you. The 1100th, the data in 1100th place. So I'm expecting this from you. I've got up to here. I'm expecting this from you, right? So then the sequence number can start from 1100, and then it will, you know, send length, so on and so forth. We will talk about this a bit more detail because this is the only thing I have learned only up to here. We will go into a bit more detail about TCP in the next video. So thank you. Have a great day. And remember, you are loved. Remember, you are cared for. Remember, do not take a permanent solution for a temporary problem. Anyways, have a great day. See you soon.